Now we're going to learn angles. An angle consists of two rays or line segments with a common endpoint called vertex. As you can see here, clockwise rotation has a negative measure, while counterclockwise rotation has a positive measure. Now, let's go to the example. How many degrees is 2/3 rotation clockwise? So, we have 2/3, and since it's clockwise, we're going to be using a negative measure. So, negative 360 degrees. So, you cancel, becomes 120 degrees times 2. Final answer is negative 240 degrees. Now we're going to learn coterminal angles. Coterminal angles are angles in standard position whose terminal side coincides. So we see here 60 degrees and 420 degrees are coterminal angles. We notice that their measure differs by 360 degrees. Coterminal angles have measures that differ in multiples of 360 degrees. Example: find the coterminal angle of 541 degrees with a measure theta such that 0 is greater than or equal to 0 degrees but is less than or equal to 360 degrees. So what we do here is 541 minus 360. The answer will be 181 degrees.
We have seen angles measured in degrees, but they can also be measured in radians. To change degrees to radians, you multiply the degrees to pi over 180. To change radians to degrees, you multiply the radians to 180 over pi. An example: express 480 degrees in radians. So what you do is you multiply 480 degrees to pi over 1/8. What happens is you can cancel and multiply, and then you get 8 pi over 3.
1 radian measure is the measure of a central angle of a circle intersecting an arc whose length is equal to the radius of the circle. So the radian measure of a central angle can be measured by dividing S over R, where S is equal to the length of the intersected arc, while R is the radius. So this formula can also be written as R is equal to S over theta, and S is equal to R times theta. Example number 1. A circle has a radius of 8 cm. Find the arc length intersected by a central angle of 144 degrees. So first you convert 144 degrees into radians. So 144 degrees times pi over 180 is equal to 4 pi over 5. So using the formula S equals R theta, so S equals R theta, our radius is 8 cm, so 8, and then our theta is 4 pi over 5. So we get 32 pi over 5 cm. Our second example is find the radius of a pulley if a rotation of 45 degrees raises the weight 7 cm. So first, you convert 45 degrees into radians. So 45 degrees times pi over 180 degrees equals pi over 4. So we use the formula R equals S over theta to get the radius. So R equals 7 over pi over 4. So this is equal to 7 times 4 over pi. Our final answer would be 28 over pi cm.
Now, we're going to learn the 6 trigonometric functions. To define these functions, we start with angle theta in standard position in an origin-centered unit circle drawn in a coordinate plane. Its terminal side intersects the circle at point P, X, Y. The distance from point P, X, Y to the origin is r equals square root of x squared plus y squared. The 6 trigonometric functions are defined as follows. Sine theta is equal to y over r, cosine theta is equal to x over r, and tangent theta is equal to y over x. Cosecant is the reciprocal of sine theta. Secant is the reciprocal of cosine theta, and cotangent is the reciprocal of tangent theta. If you have a hard time remembering these functions, just simply remember SOHCAHTOA. SOHCAHTOA stands for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Okay, now we're going to learn the signs of function values. In quadrant 1, all the functions are positive. In quadrant 2, sine theta and cosecant theta are positive. Quadrant 3, tangent theta and cotangent theta are positive. And finally, in quadrant 4, cosine theta and secant theta are positive.
The terminal side of theta in standard position passes through -3, -4. Find the values of the 6 trigonometric functions of theta. So x equals -3 and y equals -4. So you have to get r. R equals the square root of x squared plus y squared. So you substitute the values. So that's square root of -3 squared plus -4 squared. So that will be 9 plus 16 equals square root of 25. So r equals 5. To get the 6 trigonometric functions, you have to substitute the values to the functions. Sine theta is equal to y over r. So that's -4 over 5. Cosine theta is equal to x over r. So that's -3 over 5. Tangent theta, on the other hand, is equal to y over x, which is -4 over -3, makes it 4 over 3. To get the cosecant, secant, and the cotangent, you just get the reciprocals of these 3 functions. Find the values of secant B and tangent B for an angle B in standard position given the equation of the terminal side 4x minus y equals 0, where x is greater than or equal to 0. So that's 4x minus y equals 0. So that's 4x equals y. So that means x equals to 1 and y equals to 4. To get r, so that's equal to square root of 1 squared plus 4 squared. So that's equals to square root of 1 plus 60. So that's square root of 70. So r equals square root of 70. So we're looking for second b and tangent b. So second b is equal to r over x. So that's square root of 17 over 1 equal to square root of 17. And tangent b is equal to y over x. So that's 4 over 1 equals 4.
Now we're going to learn quadrantal angles. Quadrantal angles are angles whose terminal side lie along the x-axis or y-axis. Examples are 0 degrees, 90 degrees, 180 degrees, 370 degrees, 360 degrees, and more. Example number 1. Cosine 90 degrees. So cosine is x over r, and we have here 90 degrees. So x over r, which is equal to 1, so that will give us 0. And then since we have here 3 parentheses, sine is y over r. We have here 270 degrees. Y is negative 1 and r is 1, so that will give us negative 1. So our final answer will be negative 3. Example number 2, we have here tangent 360 degrees plus 4 sine pi plus 5 cosine squared pi. So tangent is y over x. So let's look for 360 degrees. We have here y over x. So that will give us 0 plus 4 parentheses pi. So pi, sine is y over r. So y over r is going to give us 0 again, parentheses, plus 5 parentheses. Cosine of pi, so cosine is x over r, negative 1 and 1. So that will give us negative 1 squared. So our final answer will be positive 5.
So since the sum of the angles in any triangle is equal to 180 degrees, and since angle C is equal to 90 degrees, then angles A and B are complementary angles, which means their sum is 90 degrees. Since angles A and B are complementary, then the functions sine and cosine are called cofunctions. Cosecant and secant are also called cofunctions, and tangent and cotangent are cofunctions as well. Write cosine 52 degrees in terms of its cofunction. So since cosine and sine are cofunctions, then cosine A is equal to sine 90 degrees minus A. So we have cosine 52 degrees is equal to sine 90 degrees minus 52 degrees. So we get cosine 52 degrees is equal to sine 38 degrees. Find one solution to the equation cosine theta plus 4 degrees is equal to sine 3 theta plus 2 degrees. So since sine and cosine are cofunctions, the sum of their angles is equal to 90 degrees. Therefore, is equal to 90 degrees. Then we add the like terms, so 4 pi plus 6 degrees is equal to 90 degrees. Transpose the 6 degrees, then we get 4 pi is equal to 84 degrees. Divide both sides by 4, and then our final answer will be theta equals 21 degrees.